Area of composite figures. So when we look at the area of composite figures, we need to talk about what a composite figure is. So a composite figure is kind of just like a weirdly shaped object that we don't have a formula to calculate the area for. So what we do is we break it down into things that we do know how to calculate the area of. So let's start by breaking this shape down. We're going to make it into one rectangle here, and then we're going to make it into a triangle here, and we're going to make it into another rectangle there. Well, this rectangle, the height is 12 and the base is 8. So to get the rectangle, I'm just going to multiply 8 times 12. So that's going to give me an area in here of 96. Let's take a look at that other rectangle. So we know from here to here is 8 inches. Well, this whole side goes 15. So to get this little nugget here, we're going to take 15 and we're going to subtract 8 from it, which is going to give us 7. So both of those lengths are going to be 7. Now we know that this is 5, which means that this is 5. So base times height for that rectangle is going to be 7 times 5, which is going to give me 35. Last but not least, let's take a look at this triangle right here. Okay, so we know from here to here is 5. We know that this entire side, meaning here as well, is 12. So to get this length, we're going to do 12 minus 5, which is going to give us 7. So we have a triangle whose height is 7 and whose base is 7. So what we're going to do to get the height, or to the area of a triangle, we do 1/2 base times height. Now, when you do that, you get 24.5. So now what I've done is I've calculated out all of those little pieces. So I'm going to add them together. So I have 96 plus 35 plus 24.5. So when you add all of those together, you get 155.5. Now I'm going to write that as inches squared because we're talking about an area, and you should be squaring your label when you're talking about an area. So let's go ahead and let's take a look now at number 2. So for number 2, we want to find the area of the shaded region. So first thing I'm going to do is figure out the area of this big rectangle right here. So to get the side lengths, we have 25 on both sides. So 25 plus 100 plus 25. Now notice when I do that, it forms the entire length of this side. So 25 plus 100 plus 25 is going to give me 150 going this way. So now let's take a look at going up the side. So going up the side of this one, I have 25, 20, and 25. So notice how that covers the entire thing, 25, 20, and 25. So going up here, I'm going to have 70 when you take 25 plus 25 plus 20. That gives you 70. So that's the area for our big rectangle, the shaded one. So 150 times 70 is going to be an area of 10,500. Now that's for the shaded, or for the big rectangle, but it doesn't include kind of that gap that we have in the middle here. So we also need to calculate out the area of this rectangle right here. So we know that this height is 20 and that the length is 100. So I'm going to multiply 20 times 100, and that's going to give me 2,000. So the area of that small rectangle is 2,000. So now to get the shaded region, I'm simply going to take 10,500 and I'm going to subtract 2,000. And once I do that, I end up getting 8,500. Now my label is feet, so I'm going to label that as feet squared. So that's my final answer for number 2. Now, let's take a look at number 3. So we have our shapes already drawn for us. First, let's start with this half circle that we have. So remember to calculate out the area of a circle. It's going to be pi r squared. Well, it's given me that the radius is 4. So 4 squared times pi. Well, when I do that, now I notice that I only have half a circle. So I'm going to take what I get there and divide it by 2 since it is a semicircle or half a circle. And when I do that, the area of the semicircle is 25.13 feet squared. So now it's asking me for the area of the triangle. So the triangle is going to be this guy right here. So what we know about the triangles, we know the hypotenuse and we know the base. What we don't know is the height, and we actually do have to know the height in order for us to get the area. So I'm just going to draw that triangle out. We have a hypotenuse of 5.7, and we have a base of 4. So what I'm going to do is I'm going to use the Pythagorean theorem to get that leg there. So x squared, excuse me, plus 4 squared is equal to 5.7 squared. So I get x squared plus 16 is equal to 5.7 squared, which is 32.49. So then we're going to subtract the 2 from both the 16 from that, and you get 16.49. So to get the height, I do need to take the square root of both. So when I take the square root, I end up getting 4.06. But now, that was just to get the height. Now I have to actually calculate out the area. So the area is 1/2 your base, which remember we were told was 4, times your height, which is 4.06. So then when you multiply all of those together, you're going to get 0.5 times 4 times 4.06. And when you do that, you get 8.12 feet squared. So that is for the triangle. So let's go ahead now and let's calculate out the area of that rectangle. So our rectangle is going to be this guy right here. So we have a base of 4 and a height of 7. So the area of the rectangle is simply 4 times 7, which is going to give us 28 feet squared. So now, in order for us to get the area of this entire figure, we need to take and we need to add each of these together. So 25.13 plus 8.12 plus 28, that's going to give me 61.25 feet squared for the entire figure. Now we're going to do the same thing for number 4 here. So first of all, I notice that I have a half circle here. But before I can do anything with that circle, I need to figure out how tall this thing is here. So I'm actually going to end up having to make a triangle. So I know that this length is 22. This entire thing is 31. So 31 minus 22, that's going to give me that this right here is 9. So I broke this off into a triangle purely so that I could get the height lengths. So I have 15 squared is equal to 9 squared plus x squared. And that's just because of this triangle right here that we're looking for the height of. So then I'm going to get 225 is equal to 81 plus x squared. So we take 225 and we subtract 81. Okay, and when we do that, we end up getting x squared is equal to 144, so I get that x is equal to 12. So I know this height is 12, which means that this height is 12 over here. So what I notice about the semicircle is that its diameter is 12. So if you remember, the diameter is twice the length of the radius. So if this is my semicircle and the diameter is 12, that means that my radius is going to be equal to 6. So to find the area of the semicircle, I'm going to do pi times my radius squared. So 6 squared times pi. Now remember, it's a semicircle, so it's only half a circle. So I'm going to then divide it by 2. And when I do that, I get 56.55 centimeters squared. So now I want to find the area of the trapezoid. So the trapezoid is going to be this guy right here. That's the trapezoid. So to calculate out the area of a trapezoid, remember it's the height multiplied by the sum of the bases divided by 2. So let's go ahead and set that up. So the area of the trapezoid is the height, which we found using the Pythagorean theorem to be 12. And then the sum of the bases, the top one, which is 22, and the bottom one, which is 31, and that all is going to be divided by 2. And if you use the parentheses like that, you actually can plug it all into your calculator. So then when you calculate it out, you get 318 centimeters squared. So the last thing we need to do to get the total area of the figure is to add these two numbers together. So when you add them together, you get 374.55 centimeters squared. So that's your final answer for number 4. Now, last but not least, let's take a look at number 5. So the first thing I need to do is find the area of this outside parallelogram here. So remember, a parallelogram, to get the area, is just going to be base times height. So my base is going to be 14. Now my height is literally has to be perpendicular to the base. That's why this right angle is here. So that means that 9 is my height. So my area for the parallelogram is simply 14 times 9. And that's going to give me 126 feet squared. Now I need to find the area of a kite. So to find the area of a kite, this is the kite that we're looking at here. The area of a kite is the product of the two diagonals. Now notice that 14 actually covers this entire diagonal because it's parallel to this base, which means that it also has a length of 14. My altitude is parallel to this diagonal, which means that my height is, or my other diagonal is 9. So my two diagonals are 9 and 14. So I multiply the two of those together and then I divide them by 2. Well, 14 times 9 is 63, and that's going to be feet squared. So last but not least, to get the area of the shaded region, I need to do some subtraction. So I'm going to take 126 and subtract off 63 because I want to take this kite out from the middle. And when I do that, I get 63 feet squared. Okay, so that concludes your note video for today. Thank you for listening.